All right, this is where things get a little bit more interesting. So this 96 assignment is pretty tricky. It requires a lot of reading, okay, and a lot of different kinds of skills, I would say. So first off, please make sure that you go through and read the instructions on this assignment. Okay, so we've got the scientific calculator on GeoGebra. That's over here, already ready from working on our 95 assignment. And then you can use your own handheld calculator if you'd like as well. And we're going to be using some formulas for statistics. There's a lot of Greek letters, a lot of formulas you probably haven't seen before, because we're going to cover them later on in the statistics class. All right. So you don't have to know what these formulas mean. You just have to read and interpret what it's saying and then use them. And then later on in the quarter, when we actually need these formulas, you'll have already gotten practice. So let's start with the first problem. Binomial distributions are a particular type of discrete probability distribution. You don't need to know what that means. That's unit 4. We'll talk about that later. We can use the following formulas to find the mean, variance, and standard deviation. You don't need to know what that means. We'll talk about it later. Just say, okay, mean is something. Don't need to know what it means. But just how can we work with it? So it's telling us here that n, let's make this at a zoom level that makes sense. The variable n is going to represent the number of trials. Do we know what trials is? No, doesn't matter. P is the probability of success. The probability of success is 1 minus q. What's q? The probability of failure. So if we have a 60% chance of success, it's a 40% chance of failure. 100% minus whatever other percent. It tells us that the mean is some Greek letter called mu, and that's n times p. So the formula here for the mean says that the mean is called mu, and all you have to do is multiply n, which we know is the number of trials, times p, which we know is the probability of success. Then there are some other formulas as well. We don't have to worry about them too much. It tells us what mu and sigma, how you say them. Let's go on to the question. Find the standard deviation for the binomial distribution, given that there were 18 trials and the probability of failure is 38%. So this is a problem that we're going to do later on in this quarter. We're doing it early. You don't need to know what any of this means, but can you find the important information to use the formula? Check this out. Well, we know we're first things first. We're looking for standard deviation. So let's write that down. Okay, we need the standard deviation. So let's find the standard deviation formula. Again, depending on how zoomed in or out you are, it might look easier or it might look nicer or worse. But this is the standard deviation formula. Sigma is the standard deviation, and that's the square root of n times p times q. Again, that's the standard deviation. And now we just need to find what everything is. So n, we already covered that. N is the number of trials. P, that said, it was a probability of success. As a decimal. And Q, I don't think we read that part. It's a probability of failure. As a decimal. So we're going to have to always convert these to decimals. Percents are great, I think, for understanding probability, but decimals are what we're always going to be using for evaluating them. So we have this formula, sigma. What we're trying to find is the square root of n. How many trials did we have? Look at the problem. Given that there were 18 trials, means that n is 18, which means we replace the n with 18. Times p. Well, p is the probability of success in the blue. What's the probability of success? We don't know. It tells us the probability of failure, but it doesn't tell us the probability of success. The probability of failure is 38%. What's 38% as a decimal? Just move the decimal 2 places to the left. It's going to be 0.38. Want more practice converting percents to decimals? There's a video for that. All right. If the probability of failure is 0.38, we know the probability of success is 1 minus that q. So p is 1 minus q, and q is 0.38. You can use a calculator that'll give you that p is 0.62. So fill in the blank. Replace the p with 0.62. Replace the q with 0.38. And now we can evaluate our formula. We have everything. Just got to plug it in. Say sigma is going to be the square root. You can write SQRT with a parenthesis. Or if you'd like, you can just click the square root button. N times P. I actually don't remember these. N is 18. P is 0.62. I got them all wrong. N is 18. P is 0.62. And Q is 0.38. What were the instructions for rounding? Round to the nearest hundredth, it says. Okay, so we have 2.05932. Remember, this is the nearest tenth. This is the nearest hundredth. Which means everything after that is going to be at 0. So does this 5 round down to a 5? Or does it round up to a 6? It rounds to a 6 because this is at least 5. So the digit after the place is what tells us whether we round up or round down. So our final answer should be 2.06 for this problem. You can type that in. And I think you only have a certain number of tries, if I remember, on this one. So I can check my answer right here, but you should probably wait until the end to check yours. And then we can see we got 6 out of 6 points. Great. And then sometimes it tells you, it gives you little reminders in case you're right or wrong. Here we're right, so we don't need this reminder. But they are going to tell us that, yeah, you have to watch out for that. Okay. The next couple are pretty similar. Let's look at number 6. P is the probability of success in one trial. Q is the probability of failure, which is 1 minus P. Okay, pretty similar. P hat, I think it mentioned how to pronounce this earlier. P hat is the sample proportion. Again, you don't need to know what this means. We'll talk about sample proportions soon. Actually, you may have already, I think we actually already covered that in 1A. The number of and it's calculated by the number of successes divided by the number of trials. If X is the number of successes and N is the number of trials, you can write it as X divided by N. There are links for some help, and we're going to find the test statistic. Gives us this formula. Test statistic is Z. Here's our formula. Let's find what we need. So we're going to know that Z, let's use white. Z is going to be P hat minus P divided by the square root of PQ over N. Now there's a lot going on here. This is a complex fraction. It's one fraction inside of another fraction. Now there's two ways of going about this. You can plug everything in directly, or you can break this up into smaller pieces. If you'd like, you can go off to the side and say, well, let's look at what is the square root of PQ over N. Once we have an answer, we can plug that in directly. Or you can just type it in all together. That's going to be the square root of P. P we know is the probability of success in one trial as a decimal, which is given to us as 0.24. P is 0.24, so we replace the P with 0.24. Q is the probability of failure, and it's always 1 minus the p-value. So we know that Q is 1 minus p. You can type that into a calculator and get 0.76. So replace the Q with 0.76 right over here. Now divide by N. N is the number of trials, it tells us. How many trials do we have? 72 trials. All right. The one way that you can do this is do it in steps, like I have written down. If you do it in steps, make sure to use a lot of decimal points in your answers. Okay? Or you can do it all at once. And this is usually gives a more precise answer, but it's up to you. P hat, we're told, is 0.21. Minus p, we have from before, is 0.24. Divided by this square root, which we already had off to the side. Now, very important to type this into your calculator correctly. GeoGebra or other online calculators make this a lot easier. Otherwise, you're going to have to use parentheses very carefully. So let's type this in to GeoGebra. So it's p hat 0.21 minus 0. Oops. I don't know what just happened. 0.21 minus 0.24 divided by a square root. Now this is one of the advantages to GeoGebra. Look what we're looking at. What we should have is the whole thing divided by the square root, right? But you can see in GeoGebra that when I pressed it like this, it only put one part. That's because we need parentheses. We're dividing this whole entire numerator by that square root. So if you put parentheses and then the division sign, then you can see that it looks like it's supposed to look. Now divided by this square root, again, you can either type SQRT with a parenthesis, or you can hit the square root button on the bottom. And now it's P times Q divided by N. And again, you can see that the division is only going over one of them. These are mathematically equivalent, but I'm going to press backspace to add parentheses around this part so it looks exactly the same as what I want it to look. Oh dear, I'm confusing GeoGebra a little bit. Let's try this again. I'm going to highlight all of this, hit the square root sign, highlight all of this, hit a parenthesis, go after the parenthesis, and now divide it by the n, which was it 76? No, it's 72. Like this. And now I can check and make sure that this looks in the calculator exactly the same as it looks how I've typed it. We'll press enter again to get our answer of negative 0.5960. And the question is, how are we supposed to round this? 4 decimal places. Oh, let's include some more then. 59603956. It wants us to round it to 4 decimal places. That's rounding to the nearest 10th, 100th, 1000th, 10,000th. So we're going to round this. The first 3 stay the same. And the question is, does it stay as a 0 or does it round up? Stays at the 0 because this is a 3, so it rounds down. We do need the 0. That's a significant figure here. We should be able to type in our answer of negative 0.5960. Oh, I already submitted it, but you should be able to type it in just like that with a leading 0, just like I have written it down. Okay. All right, last problem I want to do is another one with order of operations, but a more complicated one with order of operations. All right, let's look at number 10. So it wants us to simplify this. And it's going to be 3 plus 5 minus 2 squared divided by 1 cubed plus 3 squared plus 12. We'll do this by hand with PEMDAS and use a calculator and see how it compares. Parentheses first, then exponentials, then multiplication or division, and then addition or subtraction. So first we'll start with what's in the parentheses. We're leaving everything else completely the same. We're only doing parentheses. And inside the parentheses is 5 minus 2, which is 3. The only thing that changed. And now we do all the exponentials. 3 plus 3 squared is 3 times 3, which is 9. 1 times 1 times 1 is 1. 3 times 3 is 9 plus 12. We did all the exponents. Next is multiplication and division. Now, this is a fraction, which is division technically, but we're not going to worry about that here because we can't divide these fractions until they're simplified. So we'll do addition and subtraction last. That's 12 on the top divided by 22 on the bottom. And then we need to simplify our answer. Find their common factors. And again, if you find the greatest common factor, that's the quickest way to reduce, but any common factor will work. So divide the top and the bottom by 2 will work. And maybe we'll just have to do something more after that. 12 divided by 2 is 6. 22 divided by 2 is 11. And that is our fully simplified answer. 11's prime. 6 is just 2 times 3. And neither one of those are a factor of 11. So we can type in 6 divided by 11 here. Make sure that we're doing the instructions, whole number, or a fraction in lowest terms. Write fractions with a slash bar, such as 6 divided by 11. And let's see if we get the answer correct. Scroll down. 3 out of 3 points. We got it done. Let me know if you have questions in any of these, if you want me to check your work. Oh, I said I was also going to show how to do this on GeoGebra. 3 plus 5 minus 2. 3 plus 5 minus 2 squared. You can do a caret sign, which is shift 6, and then press 2, or you can click the exponential button for the squared, or any exponential. Press the forward key on your keyboard or this right key on this to enter the fraction. Oh, I forgot parentheses because notice we need everything to be getting divided. The fraction should cover everything, not just the second part. So I press a parenthesis button. I'm going to undo that to show you what I just did because you can't see my keyboard. All right, that was not what I wanted to do, but it worked out. 3 plus 5 minus 2 squared. So again, you can hit the arrow key and then end the parenthesis. And now we can try division, the forward slash button on your keyboard or a divide. And the bottom was 1 cubed, right arrow, plus 3. You can either hit the squared button or the other button. Squared arrow, and then I don't remember the last, plus 12. Click back, plus 12, and then hit enter. And you can again get 6 over 11. If you want a decimal approximation, there it is, or you can click the button for a fraction. Let me know if you have any questions with this. And yeah, that should be everything you need to know for that. And again, if you want more in-depth help, check out this videos for a ton of videos on using formulas and order of operations. Best of luck and bye-bye.